All right, so we're going to go into the next section of linear functions and slopes. Now, we're not going to spend a whole bunch of time in this section because we've covered slope and slope-intercept form in the previous course. Um, so just quickly, slope is of a line measures the steepness or tilt of a line. You have the slope formula where you have the change in y over the change in x, which is rise over run, and we have our slope formula. Now remember, the variable that we use to represent the slope is the variable m. There are four types of slopes. Positive slope, as we move along the line from left to right. We have a negative slope, which goes down as we move along the line from left to right. We have a zero slope, okay, in which all horizontal lines, you have a zero slope, okay? And then we have an undefined slope, and all vertical lines, the slopes are undefined. So, like I said, we're not going to camp out in this section. We're definitely just going to go through, and this will be a great review because we will be seeing these terms as we move on into the section. So, our first example here, it says find the slope of the line passing through each pair of points, or state that the slope is undefined. Then indicate whether the line through the point rises, falls, is horizontal, or is vertical. So number one, we have two pairs of points. We have 4, 6 and 5, 8. The formula that we're going to use, m is equal to y sub 2 minus y sub 1 all over x of 2 minus x of 1. Label your ordered pair, which is x, y, and label your sets. The first set of points I see, I label that with a subscript of 1. The second set, I label that with a subscript of 2. Let's find the slope. M is equal to 8 minus 6 over 5 minus 4. 8 minus 6, we have 2. 5 minus 4, we have 1. And we have a positive 2. So this slope is a positive slope in which we will have a slope that rises from left to right. Number two, so it will look something like this for number one example. Number two, we have another set of points, -3, -6, and -7, -6. Using the slope of the line formula, we have m is equal to -6 minus -6. Now keep in mind, as we label our points or label our ordered pair, excuse me, keep your subscripts the same for each set. Okay, we don't want to have x1 and y2. We want to, when we see our first set of points, give it a subscript of 1. Our second set of points, give it a subscript of 2. So when we subtract this, our change in y, we have 2 points that's identified, -6 and -6. The minus that's in the formula itself does not substitute the negative that's part of the question. So we have here that we have our numerator, -6 minus -6, our denominator, -7 minus -3, and we know that the two negatives will become a positive. So we have -6 plus 6, and then over -7 plus 3, and -6 plus 6 is 0, -7 plus 3 is -4, and 0 divided by -4 is 0. So we have a zero slope, and we know that a zero slope, all horizontal lines would have a zero slope. Number 3, we have here -8, -9, and 2, 1. Let's find the slope. We have 1 minus -9 over 2 minus -8. We have the two negatives there. This becomes 1 plus 9 over 2 plus 8. That is 10 over 10, which reduces to 1. So we have a positive 1, therefore we have a positive slope again. And this will be a line that rises from left to right. Now, had the slope been negative, it would have been a line that falls from left to right. Last example, we have -7, -6, and -7, -9. Here we go. We have negative m is equal to -9 minus -6, and -7 minus -7 in the denominator. The two negatives, that becomes -9 plus 6 over -7 plus 7. -9 plus 6 gives us -3 all over -7 plus 7, which is 0. Now, 0 is in the denominator. We cannot divide by 0. Therefore, we have an undefined slope. All vertical lines, there's an undefined slope. So this line would be vertical. So we have a positive slope, negative slope, zero slope, and undefined slopes. They're the 4 types of slopes that we will be working with.